Last class we did till reversible and irreversible process.
Yes.
Fifth one, right? Adiabatic process. Adiabatic process. The process in which gas does not get time to exchange heat with the surroundings. Does not get time to exchange with the heat with the surroundings is called as adiabatic process. For adiabatic process, delta Q is 0. Delta Q is 0. So since Q is delta U plus W, so this is 0 is delta U plus W. So we can say delta U is minus W. That means change in internal energy is opposite to work done. If gas expands, then work done is positive or negative? When gas expands, then work done is positive or negative? Positive. Then work done is positive. If work done is positive, then change in internal energy will be negative.
Yeah.
Change in internal energy negative means its temperature will decrease. And we also know when expand, then temperature falls. When contracts, temperature will increase. So process in which gas does not get time to exchange heat with surrounding is adiabatic process. So Q is 0. That means Q is delta U plus work done. 0 is this, delta U is minus W. So when gas is expanding, work done is positive. Therefore, delta U will be negative. That means temperature will fall. Please copy till this, then I'm telling you further. The process in which gas does not get time to exchange heat with the surrounding is called as adiabatic process. For adiabatic process, Q is 0. Therefore, 0 is delta U plus work done. So change in internal energy is negative. Therefore, when gas expands, work done is positive. Written,
Yes, sir.
but the internal energy decreases. But the internal energy decreases. Hence, temperature of the system falls. Hence, temperature of the system falls. Next line, when gas contracts, then work done is negative, but internal energy increases. Hence, temperature of system decreases. Hence, temperature of system decreases. Temperature of system increases. Wrong. Temperature of system increases. The PV diagram for adiabatic process is as shown. There is sudden fall in the volume. So this is pressure initial, volume initial. This is final. Here final pressure. Next we have to find formula for thermodynamic process in adiabatic condition for Q, U and W. Can I clear this diagram part?
Yes.
Thermodynamics of adiabatic process. See, whenever we say thermodynamics of adiabatic or any process, that means we are interested in what is Q equals to delta U plus W ka relation. So thermodynamics of adiabatic process. Just wait for a few minutes. For an adiabatic process, first you have to remember, for adiabatic process, PV raised to gamma equals to constant. If it is isothermal, then PV equals to constant. If it is adiabatic, then PV raised to gamma equals to constant, where gamma is Cp upon Cv. Cp, Cv are specific heats at constant pressure and constant volume respectively. Constant pressure and constant volume respectively. Gamma is also called as adiabatic ratio. For monoatomic gas, gamma equals to 5 by 3. For diatomic, gamma equals to 7 by 5. Just copy till this, then we are doing derivation of work done and internal energy. Completed. For adiabatic process, PV raised to gamma constant, gamma Cp upon Cv, Cp are specific heat at constant pressure, constant volume. Gamma is also called as adiabatic ratio. For monoatomic, it is 5/3, diatomic 7/5.
Yes, sir.
Okay. अभी delta U and work done I am finding so that we can arrange for total heat in thermodynamic system. Right. In adiabatic process, heat is not exchanged. That means it is not given out to the surrounding. Whatever it is, it will be inside only. It is not exchanged. It is not exchanged. Hence, internal energy and temperature both changes. Internal energy and temperature both changes. Therefore, change in internal energy, change in internal energy given by delta U is Cv delta T for 1 mole of gas. So I got internal energy Cv delta T. Work done, comma W is PdV from initial temperature to final temperature. But we got PV raised to gamma is constant. So we can say this is some constant C, but PV raised to gamma is C. So wherever you see P, we can write there C upon V raised to gamma. So C upon V raised to gamma dV from initial to final. That is C integral of V raised to minus gamma dV from V initial to V final. Only copy till this. Copy till V raised to minus gamma dV.
Yes, sir.
Okay. Now slowly I am explaining you entire integration concept. C V raised to minus gamma. what is v raised to minus gamma का integration? Add 1 and divide by same power.
Yes, sir.
So v raised to minus gamma plus 1. This can we write 1 minus gamma 1 in the same?
Yeah.
V initial to V final. So C into 1 minus gamma outside. This if you take minus common, it will be 1 minus gamma. If I take common, inside will be gamma minus 1. Minus minus will become plus, V initial to V final. If power is negative, we can take 1 upon V raised to gamma minus 1. Can we do that? A raised to minus M is 1 upon A raised to M. So V raised to minus of something is 1 upon V raised to that thing. Okay.
Yes, sir.
So this is now C upon 1 minus gamma 1 upon V final gamma minus 1 minus sign 1 upon V initial gamma minus 1 by integration method. Now C is actually PV raised to gamma, but C means PV raised to gamma. That means I can write this as P initial, V initial raised to gamma is P final, V final raised to gamma. Constant means P1, V1, P2, V2 type. Just copy till this. Completed till this.
Yes, sir.
Now see, C I am taking inside. So it will be C V final gamma minus 1 minus C V initial gamma minus 1. Now wherever I see C, I can write either PI VI or PF VF. In first case, I will write PF VF. So it is P final V final raised to gamma. Next C P initial V initial raised to gamma upon V final gamma minus 1 V initial gamma minus 1. So 1 upon 1 minus gamma equals 2. If I take this up, PF gamma minus 1, if I take up, So like it is a raised to m upon a raised to m minus 1. Can I write m minus m plus 1? Minus m plus 1 cancel.
Yeah.
So it will be p final. This goes up. Minus minus will become plus and v final will get cancelled. V final raised to gamma. So we get p final, v final minus p initial, v initial. Once again, see how. See. V final raised to gamma. This goes up. It will become minus gamma plus 1. So this will get cancelled. Power becomes negative when you take numerator to denominator and vice versa. So P final left out is only V final. Here P initial left out is only V initial. All of you have followed this line?
Yes, sir.
Copy till this two more line. C I took inside, then I wrote PF VF raised to gamma. Second case PI VI raised to gamma. Take that denominator power in numerator. So whenever you change, power becomes opposite. Okay, done. Further.
Done, sir.
Now one more line, then conclusion. PV is nRT.
Yeah.
So this is like nR T final, nR T initial. So we can say 1 minus gamma nR common T final minus T initial. Right, further. So work done is nR P final V final minus P initial V initial, or P final minus T initial nR upon 1 minus gamma. Done. Hello.
Yes, sir.
Therefore, in adiabatic process, work done is 1 upon 1 minus gamma P final V final minus P initial V initial, which is same as NR upon minus gamma T final minus T initial. Okay. Hello.
Yes, sir.
If this is negative, suppose that means gas is if this is positive, so gas has expand.
Yeah.
If gas expands, this becomes positive. 1 minus gamma is what? Positive or negative? See, this is positive, okay? Because gas is expanding. What about 1 minus gamma? Negative, because gamma is more than 1. So plus into minus will become what? Minus, na?
Yes, sir.
If this is minus, then T final minus T initial is negative. Negative means, can I say less than 0?
Yes.
So T final is less than T initial.
Yes.
What does it mean? Temperature decreases, na?
Yeah.
Same thing we wrote earlier. When gas will expand adiabatically, then internal energy will decrease, final temperature will decrease.
Yeah.
Correct? So
Yes,
here,
sir.
just write this one line. In adiabatic process, work done is 1 upon 1 minus gamma T final V final minus P initial V initial, that is NR 1 minus gamma TF minus TI. Thus, if gas expands, thus if gas expands, then when gas expands, then internal energy decreases and final temperature also decreases. Final temperature will also decrease. Right? Note. In adiabatic process, first PV raised to gamma equals to constant, or important for MCQs. They have given only this much. I am writing in two more formula. PV is nRT. Therefore, wherever I see P, I can write there nRT upon P. So we get nRT upon V into V raised to gamma equals to constant. Therefore, T V raised to gamma minus 1 equals to constant. Second point. TV raised to gamma minus 1 is constant, or V equals to nRT upon P. Therefore, P into nRT upon P raised to gamma equals to constant. So P raised to 1 minus gamma T raised to gamma equals to constant. हेलो एक 20 मिनट फ्री होता हूँ, करता हूँ. So PV raised to gamma or TV raised to gamma minus 1 or P raised to 1 minus gamma T raised to gamma is constant. So this 3 you have to remember, not 1. PV raised to gamma, TV raised to gamma minus 1, P raised to 1 minus gamma, T raised to gamma is constant. Completed?
Yes, sir.
Sixth, right? Cyclic process. Cyclic process. Now, as the name suggests, cyclic process means if I start from A, go to B, come back to A, that is called cyclic process.
Yes, sir.
So if I go from A to B in this path, come back from B to A, then it is called cyclic process. What is not change in cyclic process? State has not changed. Huh?
Yeah.
We started A, we came back to A. So state doesn't change. If state is not changing, what about internal energy? Has it changed or it has not changed?
Change.
नो नो इंटरनल एनर्जी तो पाथ पे स्टेट पे डिपेंड करता है ना जिधर से स्टार्ट किया उधर ही आ गया ना आप रिटर्न सो नो चेंज इन इंटरनल एनर्जी
Yes, sir.
so in that case delta U equals to 0 right the process the thermodynamic process हाँ सर अच्छा आकांक्षा यादव बोल रहे हो ना अच्छा बेटा सुनो मैं पेपर भेज दूंगा जब आप पहुंच जाओगे तभी सॉल्व कर लेना ठीक है ना हाँ जी 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 ठीक है right a thermodynamic process that returns a system a thermodynamic process that returns in a system that returns in a system to its initial state is called a cyclic process is called a cyclic process thus thus in cyclic process change in internal energy in bracket delta U equals to 0 delta U equals to 0 delta U equals to 0 the PV diagram is as shown the PV diagram is as shown Written?
Yeah,
There,
sir.
therefore, for by first law of thermodynamics, therefore by first law of thermodynamics, since Q equals to delta U plus W, so Q equals to 0 plus W, Q equals to W. Then write note, very, very important. First one. If the cyclic process is clockwise, then work done is positive. If cyclic process is clockwise, then work done is positive. Second point, if cyclic process is anti-clockwise, if cyclic process is anti-clockwise, then work done is negative. If cyclic process is anti-clockwise, then work done is negative. Seventh, free expansion. Hello? आने के बाद बोलने वाले हाँ हाँ ठीक है हाँ 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 नहीं हाँ, मैंने कर सकते हैं मैं आपको इवनिंग में तीनों जन से बात करके बता देता हूँ ना ठीक थैंक यू हाँ हाँ नो प्रॉब्लम नहीं नहीं जनरली करेंगे नहीं करेंगे आप डिजाइन करिए कोई बात नहीं कर लेंगे अच्छा ठीक है फाइन 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 हाँ मैं कदे भेज देता हूँ आपको हाँ हाँ फ्री एक्सपांशन नो एज द नेम सजेस्ट फ्री मीन्स सडनली एक्सपांड हो जाता है सो एक्सपांशंस आर एडियाबेटिक सडन चेंज को फ्री एक्सपांशन बोलते हैं उसको एडियाबेटिक बोलते हैं दैट मीन्स देयर इज नो एक्सचेंज ऑफ हीट बिटवीन सिस्टम एंड सराउंडिंग सो क्यू तो जीरो हो जाएगा सडन हो गया तो इंटरनल एनर्जी चेंज इज ऑल्सो जीरो वर्क इज ऑल्सो जीरो मतलब एक चीज है इफ इट इज बस्ट आउट तो देयर इज नथिंग कॉल्ड एक्सपांशन और कॉन्ट्रैक्शन सो वर्क डन इज जीरो delta u is also zero so such expansion where there is no thermodynamic law followed heat is zero work is zero internal energy zero such type of expansion is called free expansion like bursting of tire पूरा गैस का गैस बर्स्ट हो चला गया so what thermodynamics will apply nothing hello
Yes, sir.
right the expansions which are sudden are called free expansion these expansions are generally adiabatic hence q equals to 0 also there is no work done on the system or by the system on the system or by the system. Therefore, W equals to 0. Therefore, by first law of thermodynamics, Q equals to delta U plus W, 0 equals to delta U plus 0, so delta U equals to 0. Example you can write. First, sudden rupturing of balloon. Sudden puncturing of tire. Sudden puncturing of tires. In this case, system is not in thermodynamic equilibrium. In this case, system is not in thermodynamic equilibrium. So this chapter